The next algorithm is called multi-level queue. The basic ideology of multi-level queue is to have and to add fairness to the system. Where fairness is needed, we have n tasks, and each task has its own priority. Dealing all tasks equally, it's wrong, especially on basis of the priority. So we created something which we call as a multi-level queue. The basic working of multi-level queue would look something like this. Each of the queue has a different priority and has a different importance. Considering the system process having the highest priority and the student process being the user process consider has the lowest priority. Phenomena is pretty simple. Each process coming from a different era, from different time eras, or from different parts of the system would enter different queue depending on who are they. For example, process C was a system process, process X was an interactive process, process A was a student process, process B was again interactive, but process B was the batch process. So depending on that, each of the process would go in either of queue. Now each queue has its own priority, and depending on that, some amount of, or rather a particular process will come out and would be given to the processor. Consider we had a queue. Consider PS1, PS2, PS3 and so on for the system process. Similarly, PI1, PI2 for interactive process, PB1, PB2 for the batch process, and PS1, PS2, PS3, PS4 and so on for the student process. Now the process would go one simple way. We'll take PS1 for the system, then PI1 from the interactive process, then PB1 from the batch process, and again PS1 from the student process. So the basic idea is, depending on the priority, each one would be treated, no starvation coming into picture, and everybody has a fast processing system. In some cases we have an advanced design to this. What we do is, rather than taking a single process at a time, we would take different number of processes. For instance, from the highest priority system queue, and given one chance, we'll take 3 processes. From interactive, we may take 2 processes. From the batch processing system, we can take 1, and from the user, we can do 1. That means in this case, what would happen? Given a chance, we would have PS1 to PS3 served, followed by PI1 and PI2 getting served, followed by just a single process from a batch and a single process from PS1. So there is no starvation, but yes, they can operate on a different speed, or rather individual speed, as per the need basis.